All right, here it is, March 29th, 2021. It's after the end of the school classes, but I want to record this information to guide you on an assignment I'm going to give to you students. And that is, how do you make scale models? So I measured this table that I'm sitting at right now, and it's approximately 5.5 feet long, and it's 2.5 feet wide. So how do I draw that on a piece of paper to scale? Well, you're going to need a ruler to do this, and you have your choices. The metric system is the most convenient system to use for doing a lot of work. Everything is a factor of 10. The width of my little fingernail is approximately 1 centimeter, so you can tell that these are centimeters, 10, 11, 12, 13. Every 10 little marks between them, each one of those little marks is 1 millimeter. 10 millimeters is 1 centimeter. The other scale available on your rulers traditionally would be the inches scale. So about the length of your knuckle of your index finger from here to there, or this joint to that joint, that is approximately 1 inch. So you can recognize the two scales at a glance, we hope. Also, in the English units, we tend to do things as fractions, like half an inch is marked, and half an inch or quarter of an inch is marked, and half of a quarter, an eighth of an inch, and half of an eighth, a 16th of an inch. So these units are a little clumsier, which is why most of the world uses the metric system for the tremendous convenience of scaling things. So if I want to make a scale drawing that fits on my piece of paper, I'm looking at these dimensions. Feet, well, I can't do a one-to-one scale. The paper is much smaller than the table that it's sitting on. So I must shrink things down to something that fits on the sheet of paper. I would suggest, for convenience, I don't really need to fill the whole paper for this example. What if I were to use 1 foot in real life corresponds to 1 centimeter on this ruler? So my scale is 1 foot actual real life equals 1 centimeter on the scale. So actual and scale. Then to create this scale drawing, well, I just pick some origin and measure off a distance of 5.5 centimeters. And that would represent a table length of 5.5 feet. And then rotate it 90 degrees and choose to go 2.5 feet perpendicular to that, which would be 2.5 centimeters. So here's 1, 2, 2.5. And then just complete the square to make it very obvious to anyone looking at over your shoulders of, what are you doing? And you say, oh, well, I was trying to draw a straight line. And they say, well, you slipped. So there to scale is the table that I'm sitting at, where I could take my ruler here and say, oh, well, so this table is 5.5 feet long and 2.5 feet wide, because that's the scale I'm using. Now, you could do the same exercise using the English scale. I mean, after all, feet is an English unit, so maybe you want to work with going from feet to inches. Well, on this scale, if you were to, well, first you should check and see, well, do 5.5 inches fit if I want to do that as a choice? And the answer is yes, it does fit. Better than this pen, which just completely broke apart. But okay, so I could choose my actual scale to be 1 foot and set that equal to my scale of 1 inch. Really, everything is getting shrunk down by a factor of 12 from real size to drawn size. But I could do that, and I could measure out, here's 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 5.5 feet. And then in the perpendicular direction, travel a distance of 2.5 feet, which on the scale would be 2.5 inches. And then complete the square. Everything should line up nice as saying, oh, okay, so that's 5.5 feet length again, and this is the 2.5 feet. And so here's my scale. So in both cases, I have created a scale model of the table that I'm sitting at. The first scale on the 1 foot is 1 centimeter, has it pretty small on the sheet of paper. The second scale, 1 foot is 1 inch, fills the paper a great deal. Of the two, I guess you have to wonder, what do you want to do with this scale model? Do you want to show where it fits in the entire room? Or are you only interested in how you're going to allocate space on the tabletop? Like, where am I going to put my laptop? Well, so I see this laptop is 12 inches. Let's do this again. So it's 12 inches plus another 4, so it's 16 inches. Great. Well, that's 1.25 feet. So if I wanted to show the length of the laptop at some angle, I would have to draw a line that is 1.25 inches long on this scale. If I wanted to do it on this scale, I'd have to work on the metric side and draw it as 1.25 centimeters long and say, okay, so if your objective is to study the surface of this tabletop and say, okay, here's where I'm going to put the Elmo. Here's where the big screen TV is located. Here's where the chair is that I'm sitting at. It's actually not centered, it's here. The laptop is here. This larger drawing is a little bit more convenient for laying out the details of this tabletop. But if the tabletop is really, oh, here's this piece of furniture, and I want to show where I'm going to place it in this room, then the smaller scale is what you're going to want to work with because you want the room to fit on the sheet of paper. So everything is going to, you want the tabletop scale to be shrunk down. In fact, this scale is probably not small enough to show the full dimensions of this room. It might be. I mean, this table is, yeah, I would say the entire room could fit on this scale. What are the dimensions of a sheet of paper? Man, this is something you should know for your entire life. Here in the United States, this paper is 8.5 inches wide and it's 11 inches high. When you're writing or printing something on a printer, you have a margin, and you usually set the margin to at least 1/2 inch. If you did that for all 4 sides, then you're really removing a 1/2 inch twice from these dimensions. So you only have 7.5 inches of width to work with by 10 inches of height to work with. When we deal with astronomy, the scales are astronomical. And the point I'm trying to make is it's very, very hard to get people to comprehend the scale of objects in our solar system. So I'm creating an assignment for you students to do. And that assignment is based a little bit on the reference sheet, the mass of the sun, mass of the earth. I will actually, I need to provide you with the radius of the sun if I want to have you do that to scale. But of greatest interest right now is, can you create scale drawings of the earth with satellite orbits around the earth that are to some sort of scale? So notice you kind of have to have a feel for how big your paper is first and what the largest dimension is that you want to fit on your piece of paper before you start drawing items to your scale. So if I knew that I wanted to fill the sheet of paper as much as I could with some reasonable scale, this is the one I would choose. If I knew that I want to show my entire office, I look at the dimensions of my office, compare that to the paper space that I have to work with, and then decide on what scale I'm going to use. When you do scales, avoid crazy choices for the scale. Do not do okay. So do not do a scale that says 4/3 of a foot is equal to 1 inch. Okay, that's a crazy scale. Make it where you can define them and easily do the conversions in your head, or with just a simple conversion factor on your calculator. So examples of stuff that might work all right is to say, all right, I'm going to do a scale of an object, and I choose 1 centimeter on the scale to be 1 mile in actual. Okay, so that, good, but don't choose 3,897 feet as your actual. That's a crazy number. Pick something that you are in units that you tend to encounter or work with. Now, a mile is 5,280 feet. That's a little bit of a crazy number. There's a history to why it is that way. But I would not recommend that you do it in terms of feet like that. Now, if you say 1 centimeter is equal to 1,000 feet, well, that's great. And on the scale, you're going to have 5.28 centimeters represent 1 mile. A little bit different. Look at the dimensions of the largest object that you're going to be working with first and decide what scale you want to use. Do you want to even use centimeters? Maybe you want to say 1 inch is equal to 1,000 kilometers. So I'm not going to constrain you to say, oh, it's got to be a metric unit to a metric unit, although that is the most convenient choices to make by far. Or it has to be an English unit to an English unit, which has got its own set of issues. You'll need a calculator pretty much all the time. Here I've mixed them, metric units to English unit to metric unit. I'm not going to forbid you from doing that, but try to visualize what you want to create, how much room you have to work with, and let that guide you for establishing what scale you want to use. When making graphs, the rule of thumb is use values that are multiples of 1 or 2 or 5. And don't do anything crazier than that. Don't say, oh, it's a 4-to-1 ratio or it's a 3.14-to-1 ratio, like crazy, like pi or something. When you make graphs, this or any power of 10 times this. So 1 or 2 or 5 or 10 or 20 or 50 or 100 or 200 or 500. So let that guide you a little bit as you decide what kind of scale you're going to make here. For the actual assignment, okay, so scale models. I'm going to say the first problem is, well, to practice your circular orbits. So I want you to design a circular orbit around Earth, and this is a very special orbit. It's called geosynchronous. Geo is Earth. Synchronous means mm, uh, in step with, as if you're synchronized. You all agree, okay, at this moment it's this, at this moment it's that. So geosynchronous refers to the fact that if I were to look down on the Earth from above its North Pole, it's not just sitting there, it's actually rotating. And it rotates once every 24 hours. If you want to get really technical, it would be every 23 hours in 56 minutes. And at least when I was a kid, 4.091 seconds. But that's crazy, something I memorized for fun in 10th grade, right? Crazy. So the Earth is rotating once per day. For a satellite that is orbiting close to the Earth, it can go around the Earth about 16 times in one day. For the moon, way, way, way out far away from the Earth, it takes it a whole month to go around the Earth once. Well, somewhere between 16 orbits in one day and one orbit in 30 days is that magical orbit where the orbit is exactly one day. And if you want to use a sidereal day, which is what this is called, you may do that. If you just want to round it off and call it 24 hours, I will tolerate that this time. That's a synodic day. This is not the one you should be using, but if you just want to keep it simpler, okay, keep it simpler. So what I want you to do is, as a homework assignment, part A, given the period t, calculate orbit radius r. Okay? And then part B, draw r to scale on paper. Now, you could think of this as meaning, oh, just draw it as a line that represents that orbital radius. But really, I want you to draw a circle. Draw a circle of radius r to scale on paper. So I'm going to make up some numbers right now and say, well, what if it turns out that r is something like 50,000 kilometers? Oh, yeah. What unit should we work with for r? You could calculate it in meters and then convert it to miles, but let's agree that I want you to express your uh, answer in units. Oh man, don't lose points of kilometers. Okay, so I'm making that a requirement. I want you to calculate the orbit radius of a geosynchronous orbiting satellite in units of kilometers. And of course, that's measured from the center of the Earth. And then part B, draw a circle to scale on your paper. Now, if the radius worked out to be something like 50,000 kilometers as the radius, okay, so what would fit well on the paper? Would 1 inch equals 10,000 kilometers? Would that fit? No, because your paper isn't 10 inches wide, it's only 10 inches long. So you might pick a scale that says, hey, look, if the radius is 50,000 kilometers, that means the diameter would be 100,000 kilometers. And so maybe I should use the scale of 1 centimeter equals 10,000 kilometers. Then this circle would fit on your paper easily. Okay, so then part C, add Earth to scale. So if you decide, as an example, that 1 centimeter is equal to 10,000 kilometers, as an example, then knowing that the radius of the Earth is 6,378.14 kilometers, you would say, oh, that would be 6.378, 6.4 millimeters. And so the radius would be that. And so the diameter twice that, about 12 to 13 millimeters. So from here to there would be the diameter of the Earth. And so then you draw a little circle in the middle of the geosynchronous orbit, and that would represent the Earth to scale. Okay, so you'll need to answer part A in units of kilometers, state the scale that you select for doing your drawing. I had to do that here. I said, actual this is that to scale. Actual here is that to scale. I need to see this for part B. Part C, add the Earth to the same scale. Problem 2. The ISS orbits at h equals 410 kilometers. I remind you that means it's above the surface of the Earth, International Space Station. It orbits above the surface of the Earth. So, of course, you remember that orbit radius is the sum of the radius of the central body, such as the Earth, plus the altitude above that central body. And be careful that you work with all these in the same units. So everything in kilometers or everything in meters, just don't goof on that. So part A, calculate orbit speed V for the International Space Station. Part B, add ISS orbit to scale. All right, and problem 3. GPS satellites have a period of, truthfully, it's half a sidereal day. So you could say 11 hours and 58 minutes, and that would be good enough. So part A, calculate orbit radius r for one of those satellites. And of course, part B, add GPS orbit to scale on your drawing. There. This seems like a fine homework assignment for you students to complete. As we head out into the solar system, it's a big place out there. None of this takes us even close to the moon. Maybe I should make that as problem 4. Okay. Problem 4. Calculate the distance from the center of the Earth to the center of the Moon using your scale from the previous problems. Do not attempt to draw it. But I do want you to calculate it and tell me, all right, so if my scale, let's say this example, let's say I decided my scale is 1 centimeter is 10,000 kilometers. Great. So on number 4, I want you to tell me how far would I have to go if I could extend off the edge of the paper. If the Earth were here in the middle of the paper, how far would I have to go on whatever scale that you create to go from the center of the Earth to the center of the Moon? All right, that sounds like an excellent homework assignment. Have fun.